Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at a concept in matrices. This is a topic, of course, we had introduced in one of our videos on the introduction of matrices and how we are able to represent a matrix. So today we are going to have a small recap, and that's a correction of the general representation of matrices we had done in our last video. So we shall have that correction and then we shall move on to our topic for today. So thank you. Welcome. So last time we had tried to write a general representation for a matrix, and then we had given the element, of course, which we said we can give an arbitrary element in this part of the matrix that appears in square brackets or parentheses. So in this case, we said that the rows are represented by m, while the columns are represented by n. So in our last video, we had indicated here n. So this is supposed to be m in actual sense, because this one deals with the number, the first letter of this deals with the number of rows. So that one said and done, we'll move to today's topic of trying to look at a specific example of a matrix that we call a square matrix. So today's discussion will be on square matrix. So basically a square matrix. Now that I've said that we have different types of matrices, so we're basically going to look at the concept of a square matrix and try to see how it can be represented or what are some of its characteristics. So in this case, of course, we talked about the columns and rows. And for a square matrix, this is a matrix with the same number of rows and columns. So we said that if the rows and columns that I've mentioned, of course, in our first correction, that generally can be represented as m. This is an m. A is an m by n matrix, or we can say that A is a matrix of order mn, where m represents the number of rows and n represents the number of columns. So that one said and done. Therefore, we have said that there is a particular kind of matrices that is referred to as square matrices. So in this case, a square matrix, as I have said, is a matrix with the same number of rows and columns, which means m is equals n. Therefore, it can be a matrix of m by m or m n by n. So therefore, we can be able to say that the two matrices are of the same size and they have the same order. So this one is easy. We can say that maybe if this is A, it's even as A, or maybe we just take this one. We can see that the m by n is a 2 by 2 matrix. So therefore, these numbers can vary, and we can say that this is A. So long as m is equals n, then therefore this one can be defined as a square matrix. Of course, we are going to look at, we said in our first topic that these square matrices are made up of rows and columns. Now suppose we have a single column or a single row, then how can we be able to represent that matrix? Or let's say this is a matrix A that is made up of a single row or just a m number of rows and a column. Therefore, this is a m by 1 or m by 1 order matrix. And suppose the number of columns or just the rows are the number of course, this is just a single row, and then of course, just to give a demonstration for that, we say that these are the number of rows, and then this is the number of columns. So which means this one is made up of a single column, and we can say that A is represented as A, B, C, D. So therefore, this one is made up of one column and 4 rows. So this is a 4 by 1 matrix, and basically we can represent another one that we have said for the number of columns, and say that this is A, B, C, D. Of this one. So therefore, with this one, the number of rows will be 1, and then the number of columns will be 4. So that's a matrix of order 1 by 4. So therefore, this is also another type of matrices, but this special characteristics of matrices, or special category of matrices, we can call them vectors. Now, from our general definition of the term vector, we know that this is a quantity with magnitude and direction. So we are able to differentiate it with the term that is normally used in order to differentiate between the two, that's the scalars and vectors. Of course, we're going to look at the effect of the scalars on vectors in another video. But basically, concerning the square matrices and the concept of a vector, of course, which I've just mentioned, in case we come across them, then we can know that a 4 by 1 or m by 1 and 1 by n, these ones represent, of course, what we call a vector. And therefore, an A or maybe an n by n, m by n matrix represent what we call a square matrix. So in that case, so specifically that's an n by n, which is representing a square. So in that case, that is the difference between the two. So in any case we come across, of course, a square matrix that we have said is an n by n matrix, then we can be able to define it or know how to work it out now that we're going to look at some of the orders of operations of specific matrices. So for that case, thank you, bye.